All right, let's look at the Theorem 2, converse of Theorem 1. All right, now we have the parallel postulate. We can establish the converse of Theorem 1. All right, so it says this. If you have two parallel lines, then alternate interior angles are congruent. All right, so let's do that. So I already drew a picture, and I'm going to kind of refer to these points. It's just easier to write the proof. All right, so intersection between the transversal and the L is A, with M would be B. And I'm going to place C on L, different from A, and D on M, different from B, and to make sure that the C and D are opposite side of the transversal T. All right, so let's go from there. All right, so alternate interior angle, I'm going to focus on these two guys right here and right there. All right, so I'm going to say there are two possible cases. We say angle BAC are not congruent to angle ABD. Or they are congruent. So can I just do that? All right, so this is all possible cases. All right, so let's pick on the first case. All right, assume that angle BAC is not congruent to triangle ABD. Alright, so this is case 1. Alright, so if they're not congruent, their measures are different, so one must be larger than the other one. So I'm going to assume, make an extra assumption. I'm just going to go ahead and assume that that angle BAC is going to have a larger measure than measure of the angle ABC. Actually, this was ABD, sorry. So this should have been, this is D and that's D, ABD. Alright, so this guy is larger. So what you can do is, if you have a larger angle, we can cut it down. So there should be some ray AD. So I'm going to construct the ray AD such that it's going to match the measure with angle ABD. Right? So 5. So we have there exists a ray AD such that and angle BAD is going to be congruent to angle AB. Oh, actually, sorry, D is already used, so I have to use something else. So this should have been E. How about that? All right, so it's AE. So BAE is congruent to BAD. Right? So we have that. All right. So you have we can extend this guy. Let's see, so this is just an angle. Angle construction theorem. There. Alright, 6. Alright, I'm going to let L prime, which is going to be the line defined by A and E. Alright, this guy is going to be, since congruent corresponding, sorry, the alternate interior angles are congruent. So line AE, which is, I'm going to call it the L prime, is actually parallel to M. So we know that, right, so there exists such that the L prime is going to be parallel to M. So this is coming from Theorem 1 because we have a congruent alternate interior angle because we constructed that way. All right, so we're extending this into a line. All right, and also by definition, A is on that line. Alright, which is a contradiction, which contradicts axiom P1. Right? So therefore, we already got the contradiction. Therefore, we know that angle BAC is congruent to angle ABD. Those are alternate interior angles. So this is by rule of elimination. Case 2. Right? So that will establish the converse of theorem 1, which is theorem 2. Right? So as long as you have parallel lines, alternate interior angles are always congruent. Right? That's it. I hope that this was clear.